Hello ladies and gents, welcome to week 4 part 2. So make sure you go and watch part 1 where we made a chatbot that was deployable to your website. Last week what we did is you just sort of like mimicked me what I was doing, but this week I actually want to get into the why and how everything works. I'll post the link to this Notion document I made in the description, so just click on that and hopefully you can just follow along with me here. So what I'm going to do is read through most of this and sometimes refer to the build from last week, so I'm going to switch back and forth between the two. There's a lot of information here, all of it I think useful, but again you can just click on the link and just have a read through it in your own time. All right, let's go. So Voiceflow LLMs. AI basics. So AI involves teaching computers to do things that humans can, like understanding language. A robot learning to identify cats and dogs. We show it many pictures of each and it starts noticing patterns. Dogs often have longer noses, while cats have sharper ears. Gradually, it gets better at telling which is which. LLMs, or large language models, they are big computer programs that understand and generate language models like GPT. They learn from lots of text and can guess the next word in a sentence. It's sort of like training your brain to recognize patterns. By the way, GPT stands for Generative Pre-trained Transformer. It's a type of AI model designed to generate text. And here I've got a little visual to sort of encapsulate the brain, so to say, of the AI and its synapses firing off to its nodes. So it actually gets all this stuff gets stored in a thing called nodes. It's sort of like the neurons in our brains. This week what we did is we made a thing called a knowledge base. So I'm just going to flick back to Voiceflow and go to our week 4 YouTube video. And if we press 2, we put in the URL of our website. And when we did that, I might actually delete it and show you what's going to happen here. So let's go URL, HTTPS. And URL. See what it says? It says it's processing vectors. This is what I'll be talking about in a second. So what are these vector things? Voiceflow knowledge base is different from the way GPTs collect the information. So Voiceflow uses a special database called a vector database, and it is used to organize and understand different types of information. It uses things called chunks and vectors. So again, let's flick back to Voiceflow, show you what these chunks are. Chunks are these options here. So if we have a chunk limit of 3, and just save that, and we go onto preview, let's ask it a question. What I might do then is I might add a data source. Let's go Wikipedia and docs. Data source URLs. So this time it's processing the vectors, but it's taking way longer to do stuff in the background. Okay, so it's successfully added the knowledge base. Let's have a look actually what's here. Taxonomy, domestication, and breeds. All right, let's try ask it something like. So this is with 2 chunks, by the way. So what type of breeds are there? Let's see what it gives us. Okay, so this is a better example. I said 2 chunks, and these are the chunks. So that's chunk 1, and that's chunk 2. If I said it 3, it could grab 3 different chunks and then use those to help with its answers. So let's talk a little bit about vectors now. So vectors are like points or arrows in space, but this space can have many dimensions, not just the 3 we see. Each dimension can describe a different feature of something. So they help us turn things like words into a form that computers can easily understand and compare. I might just keep reading and I might jump back to that diagram up above. Embeddings. Imagine you write the word apple and grape on a piece of paper. In AI, we turn these words into numbers called embeddings. So the computer can see they are similar. Apple might be represented with an embedding of 785, and these are respective things. Grape might be represented by the embedding of 837. And these embeddings are shown as vectors. So for example, a vector or an embedding here might be, if you look at the bottom left here, that might be an embedding of the color yellow or orange. If you go to the top right or the bottom right here, the embedding might have had to do something to do with the color purple and maybe sweetness. Again, mostly like citrusy things won't be sweet, and apples and grapes are usually quite sweet. And so just to go a little bit more into embeddings, embeddings are vectors, but not vice versa. Embeddings specifically help AI represent linguistic terms like words and sentences in a way that capture the meanings, relationships, and context. Another example of this is if you type the word king, queen might come straight after, since those two are very closely related. And there's also a thing called cosine similarity, and it's a way to help measure how close these embeddings of vectors are. So I'm actually going to go through the maths in a sec, but I just want to look at this diagram a little bit and just admire it for a sec more. So usually in Voiceflow, these embeddings or vectors, they are not stored in a 3D space that we see here. I've only limited it to 3D because that's what we can see in the world around us. This is actually stored in like a hyper multi-dimensional space, and that's that is just the way the computer will read it. But for us, just for simplicity's sake, this is how it looks like. Okay, so for this part, I'm going to go through the calculating a cosine similarity number. Similarity is important because it gives a number on how well your responses are in your product. So for the chatbot you made for your client, for example, the client said he wanted a response X from the chatbot that you made for him, but it's giving a response slightly different than X, but it's just a little bit off. So what you can say is, I've given it a score of between -1 and 1. 1 means it was very close to what you wanted. 0.75 or more is good, and I will leave the chatbot as it is. I will not work on it anymore because the cosine similarity score is greater than 0.75. So this will stop the client from coming back to you every once in a while to try and fix the chatbot up. All right, so how do you actually calculate all this? So what I've done is I've assigned the features to apples and bananas. So I've assigned sweetness, color, and vitamin C content. Now the embeddings, the respective embeddings for apples and bananas are 8, 7, and 5, 9, 10, and 3. And how you calculate cosine similarity is you grab the dot product on the numerator and you divide it by the like the length of the distance in 3D space in this particular case, and then you divide those two things together. So here are our vectors, and to multiply it to vectors like this, you go 8 times 9 plus 7 times 10 plus 5 times 3. You work all that out and you get 157, and the lengths of the distances are, for apples is this, for bananas is that, and then to calculate the dot product, you grab the 157 and divided by our two results here, which ended up being 161.69. You divide those two numbers together and we get a cosine similarity score of 0.97. And what this means is that the bananas and apples and those respective embeddings that I've chosen for them shows us they are very close and similar to each other. So let's talk about the difference between last utterance and last response. So last week we made, we made this, and in Voiceflow we got to capture a thing called last utterance. Now, last utterance is the user's last typed in sentence. The last response is what the AI responded with. So for example, the question was, how can I help you? And then you answered, I'm looking to buy a car. This is then stored as the last response. And then the AI would respond with, okay, let's have a search of different cars. And this is the last response. So what I mean by that is, in here you can have two options. So you can have last utterance or you can have last response here, the thing that I'm highlighting right now. And then in Voiceflow, we also have these things called intents. So what are intents? Intents are about the purpose or goal behind the user's message. When someone interacts with a conversational AI, they do so with an intention, like asking for weather updates, ordering food, or inquiring about a business's hours. Voiceflow recognizes these intentions based on the user's input or utterance. For example, they might say, hey, I want to order pizza, add pizza to my order, or I'd like to buy pizza. These are all different utterances, but they all map to the same intent, which is ordering pizza. Entities, on the other hand, are specific details about the user's utterance. So, for example, some things you could grab from the intent is the date, the number, the name of a town or city, type of thing, type of food. So, for example, in the pizza example, the type of pizza would be a pepperoni pizza. So the intent would be the pepperoni, and the intent is I want to buy the pizza. Two more examples here if you want a bit more. The intent is, in this sentence, I want a cake for my birthday. So the intent is I want a cake, and the entity is the chocolate cake. So chocolate is the entity. Another one here is someone's looking for a 128 gig RAM Android smartphone. The intent is they want a phone, and the intentity is the 128 gigs. So the differences between entities and variables, and I might in a sec actually make an example of all this in Voiceflow so you can see. In Voiceflow, entities and variables are both used to store information, but they serve different purposes in the context of conversational AI application. Variables are used to store and change info during the conversation, like the size of the pizza. So if the user says, I want a large pizza with pepperoni, blah, blah, blah. Look, what I'm gonna do is I might actually just make this in Voiceflow so it makes a bit more sense. So let's create a new assistant. Let's call it pizza. Let's create assistant. I'm actually going to Control A, that selects everything, and then press delete. Good. So I'm just going to press M. Create new variable, and we will call this pizza size. Now, with variables, we do prefer to have the first word small, like not capital, and then the second word capitalized. I think it's called camel text, something to do with camels. Create variable, and there we go. We've created our first variable. I'm going to press escape to get rid of that. I'll go on the left hand side here and pressing that, and what we'll do is we'll create a new intent, and we are going to call it small. So for the different types of sizes of pizza, so small, medium, large, and the intent will be, so in here you can type in different words that different people might type in when they're looking for this type of thing. Want a small pizza? What about just small pizza? And I might just leave that there and create intent. In the entities, let's make this the topping. And select type. So here you can actually select the different things which are already preset. These are pretty good to use. So say you want to capture the phone number from the conversation, from the intent. Actually pretty good at picking up the number. So if the user says my number is this and my name is this, it'll actually pick out the phone number from that. But in this case, we are going to make a custom one. Might just change the color, make it blue. And for the entities, let's go make it, we're going to have two toppings. We're going to have pepperoni, that's one. And we'll have a black olive topping. So they might type in black olives or black olive. And that's our two toppings there. Let's create the entity. Press 1 to go back to our designer. Go to the talk icon here and grab text. And we'll say, what size pizza and topping do you want? And then we'll just connect the start and this new block together. I might do the same thing I did in my first video and just call this the start. And again, just color it green. Okay, and in here, because we want to capture a couple things. So they could either say small, medium, or large. If you just use the capture node block here, you could. But the easier option is to use the buttons block. So I'm going to show you a couple extra things here. I'm just going to drag it and drop it underneath the question. And what buttons does is you can add a few intents here. So you can have a button for small pizza and you can attach an intent to it. If we select this and then drag or click on small, this is this intent that we created before. And we can actually assign an action to this. So if we go press plus, and here we'll have a bunch of things going on. I'm going to click on set variable. And then the variable we want to select is the ones that we created before. So we created pizza size. And let's say our small pizza is 5 centimeters, and then I think that's it. And then we just go back here. And if you want to add extra options for the person to click on or type into, click on the add button, and then we can have medium. Do the same thing. We go on to attach an intent. And you can actually create intent from this menu as well. You don't have to press 3 on the left-hand side. You can actually create an intent from here as well. So we're just going to call this medium, and you will repeat the same process we did for the small. For the sake of the video, we will keep this a bit shorter. And then you would repeat the same thing for large, and then attach the intent and the action as well, and for the variable. Okay, so I think we are missing one thing, but just for the sake of it, let's test this out. So it'll say, okay, so you want, and then press shift under the curly bracket and bring up, so you want a pizza. So you want a pizza size of pizza size. With a topping of, is this correct? And let's see what happens when we go through this. Now we will have to train our bot as it goes through. So let's test from here. I've trained it and let's see what it does. So I'm going to type in small. You can choose the buttons here, so you can click on the buttons, or you can actually type in the word small because we set up the intent that way. And it says, so you want a pizza size of 5 with a topping of something didn't work. So what you can do is click on, where was it? here. So you can click on the left hand side and on this like little thing, you can barely visible, and you actually see that it popped up, it picked up on my last utterance, which was small. It picked up on my pizza size, it was just 5, but it didn't pick up my topping. So to fix that, what we need to do is go back into our buttons block here, and then go to the small intent, then click on the pencil, and we're going to have to change something at the bottom here. So that something is the entities. See there's a little plus button, click on that, and we can actually select a topping here, and it comes up like a little missing prompt button here. So we'll just say if the user did not give us the topping at all, what we could say, what then it would say to the user is, can you provide me the topping? So this is what you type in here to try and prompt the user into giving the thing that you want them to give you. Now we need to change our utterances slightly. So what they could now say is small pizza with some type of topping, and the toppings we had was pepperoni and whatever else. Small with topping, small pizza. And by the way, I am just pressing shift on the square bracket. I'm just choosing the thing like that. So I want a small pizza with this topping, pizza, small, and then just the topping, so without anything else there. You don't need to click on like save anything. The only thing we will need to do now is to train our assistant. And press play and we'll come up with the prompt here before we play it. Okay, so I've trained it. I'm just replaying it now. Let's type in what size pizza and topping do you want? Small with pepperoni. There you go. It picked up that we want a pizza size of 5 and that we want a topping of pepperoni. Is this correct? And then you could keep going with the conversation, and then you could have another button that agrees with this. So if they said no, so you could have again a button. So you could have no, and select an intent of no, and then add a button, and then have yes, attach an intent, and then yes. And that's how so the user can type in or click on the buttons with no or yes, and it'll keep going with the conversation. Anyway, this is an example with intents, entities, and variables. Hopefully that helped you understand them a little bit more. I'm going to go back into our last week's video. And what we talked about in last week's thing was using the memory function. So what we did is we typed in this JSON thing, JSON.stringify. Now, as the conversation goes along, as it collects the entities and variables, whatever else, it gets stored like so. What the stringify function did is that it makes it into everything, so everything's in one row, and it's easier for Voiceflow to read. Okay, I want to show you something a little bit with tokens as well. So if I type in, "Hi, can I help you today?" and go to debug mode and make sure that's on, it'll show me how much stuff costs. So I'll just say, give me one breed of dog. Cool. So it gave me Labrador Retriever. If I look at the numbers here, the total was 784 GPT 3.5 Turbo. It doesn't cost 0.75 of that. So our token cost was 583 for just that one query or question. So what is the cost of all this? In general, 4 characters is 1 token. So 1,000 words would be about 750 tokens. In most builds, you should experience anywhere between 500 to 4,000 tokens per user question. But for the sake of it, let's pretend it's about 3,000 tokens on average per query. Again, I'm no expert. This is just from my own experience, and this might differ in your own setup. from memory, it was about $5 per 2 million tokens. So one token query will result in a cost of I'm going to change this from cents into dollars. So it's going to cost you $0.0075. So if the user on average asks about 5 questions per like interaction, it's going to cost you $0.003. There's also a cool thing here called a tokenizer. You can just type things in here and check out how much stuff is going to cost you. So say I want to buy some whiskey for New Year's Eve because it's the end of 2023 and we're about to have New Year's. There was 74 characters and it was about 20 tokens. If you just do some quick math, round up the 74 to 80, divide the 80 by 4, you get 20 tokens. So let's go back into Voiceflow. And in here, we had a thing called Response AI. And we had 2 options, AI model or the knowledge base. AI model in this particular case is trained on GPT 3.5 Turbo. So if we just have a look in my Notion document, the AI knowledge base is a knowledge base the LLM you are using has been trained on. Usually there are cutoff dates for each LLM. So in this particular example, GPT 3.5 Turbo, the cutoff date of its training was in September 2021. It can take a maximum of 4,096 tokens, whereas 3.5 Turbo 16K can take 16K tokens. And if you notice, we also had the knowledge base response option. And what this does is it uses the documents we have set up in our knowledge base. So when you press 2, these are the only 2 things it's going to use. So just to show you, so at the moment it is set to knowledge base. If I type in anything else other not to do with my website or dogs or animals, it won't spit anything out. So let's type in I want to buy whiskey, and it was unable to find the relevant answer because it was not in my knowledge base. And we are reaching the end of the video, where at the end of it I just have a little bit about natural language processing or NLPs, and the difference between that and LLMs. Basically, LLMs are a subset of NLPs, and I've got a little visual here for that. So in artificial intelligence, we have machine learning, computer vision. So this is when you use GPT-4 and you upload pictures to it and can actually decipher what's on the picture. That's that. The thing that we work on when we use something like Voiceflow is NLPs. So this thing here, and everything along here is a subset of that. So speech recognition, text to speech, intents, entity extraction. But yeah, so here is the visual of that. And if you want the more wordy version, it is here. I won't go through it though. At the moment, it's been quite a long video already. But I did forget one more thing. Let's just scroll back up. I did say I was going to go through this slightly. So let's just zoom in. So when we uploaded a document to our base before, if you notice, there was like a little spinny thing, right? And it was saying something to do with vectors, is processing them. So when we upload a document or a link, so this is our document, a link, it then gets split up into chunks. And those chunks were the numbers that we could choose when we are setting up our system prompt. So the information that we give it gets split up into chunks from all the different documents we give it or links. And then those chunks are put into a vector database using embeddings. So for example, there might have been 2 embeddings that are closely matched, and that's why it made them into blue 1 and blue 2. There was one about the color purple and another one about something completely different called gray. So when the user asks the chatbot, do you know about blue stuff? So what the what the AI will then do is then grab these and then either like it will read both of them and then decide whether to use both of them or one of them, or fuse both of them together, so they can technically also overlap in its answer. And by the way, if you know maybe this works a little bit differently, maybe the chunks of vector databases work slightly differently, please tell me. I'm really keen to learn all this stuff. I'm just trying to share something that I've learned over the past 3 months. So again, I'm no expert, just trying to help you guys learn what I've also picked up along the way. So thank you for watching this week's video. You can contact me via my Twitter. You can message me on there. I can help you build something, or just spend 30 minutes for free with me. Thanks for watching and signing out.